Yeah, thanks, thanks, folks, for this opportunity. So I'll be talking about like ServiceRouter, which is like the service mesh at Meta. Before I start, let me just introduce myself. I've been at Meta for around like a year now. I lead the RPC side of things for Meta, and before this, I was working at various companies on the RPC stack for about a decade. As Ratul mentioned, like Netflix and Apple were two of them. Right. So today, whatever I'm talking is basically based on the paper of ServiceRouter that we published a couple of months back. I can't cover, of course, like for time constraints, the entire paper, but what I'll be talking about is essentially I'll give some idea about the data usage as to how we use ServiceRouter internally, a little bit of a high-level architecture about ServiceRouter to make you understand as to how this works. One of the key aspects of ServiceRouter is like optionality, that we give various form factors and which folks can use it inside Meta. So I'll cover a bit of that and design choices, which may be interesting for this group. Numbers, ServiceRouter has been in use in Meta since 2012, which makes it over a decade. We've been running on like millions of instances, in the order of millions of instances, routing around like tens of billions of requests per second through like tens of thousands of services that basically acts as the target services for these requests. One of the key design principles of ServiceRouter is that it's an embedded library, much like the gRPC proxyless thing. And based on our research, what we have seen is that using that embedded library design is saving us like tens of thousands of machines for us, if we were to use like a sidecar, as an example. The other like very interesting and I think kind of a distinct value add from ServiceRouter side is that it inherently supports sharded services, which is essentially like 68% of RPC traffic at Meta, which is a huge deal for us, right? Like, so a lot of services are actually sharded. So providing the same library which handles sharded and uncharted is a big deal. So how do we do it? This is basically a top-level architecture for this. A critical part of it that I think we've been discussing in this discussion previously is actually around like the control plane data, which we call as like routing information base. It has like service discovery data, routing configuration, and cross-region routing information, which I'll talk about a little bit later. This whole routing information is essentially like stored, replicated, and distributed to various ServiceRouter instances in our fleet through our in-home like data distribution layer. This information gets to ServiceRouter libraries, which essentially like as it routes requests, it publishes logging and monitoring information. Which going through our data warehouse gets to the independent controllers, which in turn like augment the control plane information, like the cross-region service. So as I said, like one of the power of ServiceRouter is essentially it is offered in multiple form factors. The predominant one being the embedded library mode, which is like gRPC proxyless. The other thing is essentially around like which we call look aside, in the sense that if you can't embed your library for memory reasons, you can actually like hold a lookup kind of functionality, a look aside balancer. Sidecar model, which is popular in the service mesh space, is also provided as a form factor for ServiceRouter for some users who can't embed that library. And there is another form factor, which is actually around like complete remote proxies. So instead of your like local sidecar, you can actually have a remote proxy. Since they have like multiple optionality, we kind of like give some guidance around like when to use what. But like TLDR of the slide is that most of the traffic is actually through the service router embedded library. To the more interesting part of this presentation, the key design choices that we went through. One of the things was like the sharded service support, which is a bit unique for ServiceRouter, as we have seen. To give you a reason as to why. What this graph is essentially telling you that aggregated over a week, This is the traffic distribution for unsharded versus sharded. So if you can look at it, it's roughly like the traffic for sharded services is double what is unsharded. So it's a considerable amount of traffic in our system. On top of it, like from in terms of like the containers and like the services that actually serve that shard services, you would see like it's the sharded replicas are 2 orders of magnitude more than actually unsharded service containers. And I kind of mentioned before, 68% of all RPC traffic in Meta is sharded. And to give you a bit of a variance of this information, this percentage is not included Memcache. It's not including Memcache, which is a huge service inside Meta. If we do include it, that percentage goes up to 92%. So it's a huge deal for us to actually support sharded services. So like that kind of gives you an idea as to why we need to do that. Let's see as to how. So one of the like key principles of this design is essentially like the sharded services work alongside unsharded services with as low as a cognitive overhead that you would, right? So on the left side, what I'm showing is essentially service discovery data for unsharded services. And on the right side is the sharded services. So if you look at the difference between these two is essentially what we call as a shard map. The IP and port information remain the same, there's just service discovery essential. And what in turn it gives you is a list of shard per host as to what it is hosting. There are 2 primary information in this shard map, which is one is the role of the node, where a primary and secondary, which is a typical like concept in sharded services, and the other is the key range in which it is actually the key range which this shard is responsible for. This instance is responsible for within this shard. It is a 128-bit key space which we have essentially like which you can spread your data on. And the usage of it, as I was kind of saying, that the power of this is that the least amount of cognitive overhead that you have to actually do to use sharded services is the only thing that changes is while creating the service router client, you additionally provide your key, which is essentially maps to a particular shard, and the role that you want to get to, which makes it like super simple for anyone to use. On top of it, like even that shard map that we are talking about, it is actually managed by a common shard. Right? So you're basically not every service actually has to go about and figure their shard management out. There is an alternate way of actually using sharded services, which is consistent hashing, which is used inside Meta, but like it is, the shard map is used 5 times more than the consistent hashing. And again, as I was saying, like the power of this is that both sharded and unsharded services use everything else that ServiceRouter provides. The other thing that I would cover here, let me just get a time. Okay, pretty good. The other thing that I'll cover here is essentially global routing. So it should come as no surprise that Meta has data centers globally, and many services are deployed in that format, right? But even though the capacity is global, we still, like if you look at this data in our data center environments, the RTT latency for in-region traffic is 116 microseconds, whereas the P50 of cross-region is like 35 milliseconds, right? So the fact that capacity is available globally doesn't mean we can route all. So locality awareness is super important for us. So that's kind of what we have built in. But at a high level, if you look at this problem, it is talking about like 2 constraints. One is capacity, which is essentially like all over the globe, you have capacity and you ideally want to utilize it optimally. But you also have latency constraints that you want to get to. So a request which should be done in like sub-milliseconds cannot go across. So how do we do this? So at the core of this, excuse me, there is one thing, a concept which we call latency links. There is a monitoring service, which is essentially like latency monitoring service, which monitors RTT traffic across different regions and kind of like fills these data centers into these rings. So the 5 millisecond or 35 millisecond in this example is essentially the RTT within that region. So any regions which are within the 35 milliseconds RTT would, in this example, go to range. Now, as I told that latency along with capacity is what we want to care about. So essentially what we get from users based on like tests as to how they have done on their service, that what is the safe limit for a particular region to run at in terms of utilization. And let's say it is like 65% or 80% in some cases, right? So what they say is that augment this latency ring information with this capacity information, that I want this data, this region to be at this utilization overall. And based on these two inputs, the cross-region routing service creates this kind of matrix, which essentially says, okay, region 1 to region 2, region 1 should route 45% of traffic to region 2 and 55 to region 3, which essentially this matrix get published to all of the service router instances, and that's how it kind of like defines the cross-region boundaries. So that helps us kind of like establish with like a sort of a central primitive that every service router can define what locality that it belongs to. To give you an idea as to how this behaves in production, this is production traffic for the front of the service. And if you look at like the top dashed lines, they are the utilization targets for different rings. If you look at like between 9:50 and 10, there was a spike in traffic for one of the regions, which kind of like came down because that traffic got distributed over multiple regions. So it's the peak, and then it kind of like got distributed over different regions, which basically made sure that all regions are equally distributed, none of them overloaded, and within the CPU target that we were looking at. So that kind of like gives you a high level idea about like what service router is, what are the design choices. And of course, like I can't cover all the things in detail, but I felt these were the important things to kind of like think about. Right. So I think I'm good on time. So yeah, there are 3 questions that we can take.
Thank you again. I think this was a great introduction. The thing I liked most when I kind of read about it was I think how you kind of leaked in an important application layer concept of sharding into kind of service mesh. Kind of made me think like, are there 2 or 3 more things that come up in Meta's workload that you kind of thought about? Can I bleed in just this one thing and like, and suddenly this thing performs even better or something like that? Or this was just the one and the only example you could think of where making service mesh aware of this application kind of data layout, so to speak. So I'm kind of curious about whether there are other similar things or not.
I think when we look at like different service shapes, sharded service do come at top as from the terms of data, right? Like, but from the like we do get kind of requests over time as to how do I do X within a service, like which is very specific to a service. But one of the things that essentially, I mean, which may be somewhat overlapping with other things, but like the things that we are working right now, one of the things is essentially like security around like authorizations and role-based control, which like is overlapping with what other service meshes provide. But like the fact that we are kind of homogeneous lets us introspect payloads in the data to actually make those decisions. So I think like that comes sort of like on that path where like it is somewhat application specific because we're looking at payload, but still is kind of like service mesh. I know whether that answers your question, but that's the thing that comes to mind.
I see. I had kind of similar question on the other end. You have this, you talked about you have this kind of load balancing abstraction across regions. Does that so is that kind of, you found that abstraction to kind of fit the needs of a lot of applications, or were some applications expecting like even finer grained load balancing behaviors?
So I think, I mean, the one that I did mention here is only along global routing. We do have like a algorithm of load balancing once you get within a region. There are at least like a couple of options that are available for folks inside, and they have been like mostly okay. Like most of the questions that we feel are essentially like why my load is not balanced versus essentially a new load balancing algorithm. But like we haven't got to a place where we have to define a new load balancing algorithm for services. Essentially.
Got it. We've got a question on the chat from Pooja. Where do service router instances run typically?
Oh, this is all within Meta data centers. As I said, like there are a few form factors which are like embedded in the application itself or in the sidecar, but it's everything within Meta's data centers essentially. Was that the intent of the question?
Is that what you meant to ask, Pooja?
Oops. Yes, sorry, I was muted. Yes, for the most part. So I was wondering, would router typically, I mean, I think you described it in the context of GSLB. Would it actually run even per edge where the edges can act like routers? Say, for example, in a typical CDN scenario, would ServiceRouter kind of make edge into a router and then edges can make intelligent decision as to where the egress traffic should go, or is it all just for ingress traffic and GSLB kind of decisions?
No, it's a great question. So actually, like for the edge traffic, we have another library which is open source called Proxygen, which is essentially like it does most of the routing at the edge to DC layer. Once it is within the DC, all traffic is basically taken care of by ServiceRouter.
Ah, gotcha. Okay.
All right. Well, thank you, Nitesh, again. This was great. As I said, like, I know folks have more questions and feel like we're rushing through, but like I said, I think we will come back to all of these pending questions and have a broader discussion later on in the panel. So please hold kind of your thoughts, and we're also taking notes for things we're not getting to.